going to look at the Leetcode problem 347, chop k frequent elements, and given an integer array nums and an integer k, return the k most frequent elements. You may return the answer in any order. So example, input nums is equal to 1 1 1 2 2 2 2 2 3, and k is 2, and the output is going to be 1 comma 2. And example 2, the input nums is equal to 1, k is equal to 1, and the output is going to be 1. So here the goal is to return the k most frequent elements in an integer array. So let's look at some of the possible approaches. We can use hash map and sorting. The idea here is to use a hash map to count element frequencies, then sort the elements by frequency in descending order and take the top k. And the advantage here, it's simple and intuitive, and the disadvantage here is sorting takes O of n log n time, which violates the follow-up requirement of a time complexity better than O of n log n. And the next possible approach is using a hash map and a min heap priority queue. Here the idea is to use a hash map to count the frequencies, then maintain a min heap of size k to track the k most frequent elements, and we are going to add each element frequency pair to the heap, and if the heap size exceeds k, we remove the element with the smallest frequency. And the advantage here is it's efficient for large data sets with heap operations at O of log k. It meets the follow-up requirements since O of n plus m log k is better than O of n log n. M is the number of unique elements, and the disadvantage here is slightly more complex than sorting due to heap management. And the complexity here is the time is O of n plus m log k, and space is O of n for the hash map and O of k for the heap. And then the next approach would be hash map and bucket sort. This is one of the possible a very good approach, and but we are going to use hash map and min heap now in this video. So this one with hash map and bucket sort. Here the idea is to use a hash map to count the frequencies and then group elements by frequencies in buckets. That is, index is equal to frequency. Iterate through the buckets in reverse order to collect the top k elements. The advantage here is that achieves O of n time complexity, ideal for the follow-up requirement. The disadvantage here is it requires O of n space for buckets, which may be less efficient than a heap when k is small. So the complexity here is again time is O of n and space is O of n. And hash map and quick select. Here the idea is to use a hash map to count frequencies, then apply quick select to find the kth largest frequency in average O of n time. The advantage is that the average case O of n time complexity, and the disadvantage is that worst case O of n squared time and complex implementation, and it's less reliable than heap or bucket sort. So first we are going to look at hash map and min heap priority queue approach. And here I'm going to use hash map and min heap approach, and the time complexity, as I mentioned previously, it's O of n plus m log k, where n is the array size and m is the number of unique elements. And since k is less than or equal to m, this is better than O of n log n, satisfying the follow-up requirement. And the space efficiency here, the heap only stores k elements, making it more space efficient than bucket sort, which is O of n space when k is small relative to n. And it's very simple. While not as simple as sorting, it's more intuitive than a quick select and avoids the worst case quadratic time. And the robustness, it handles all the edge cases. Example, single element k equals the number of unique elements reliably. And so compared to bucket sort, the min heap approach is slightly slower because the time complexity is O of m log k versus O of n in the bucket sort approach, but uses less space O of k for the heap. And O of it bucket sorts, it uses O of n space for buckets. And so let me start coding. So the first step 1, I'm going to count the frequency of each element using a hash map. Step 2, use min heap to keep track of top k frequent elements. let me run the code now. So here there seems to be some typos here. Yeah. Yes. And okay, now I'm going to run this. Yeah, there's a typo here. Okay. That's good. So now I'm going to explain the code. So here the first step is where we count the frequencies. I'm creating a hash map to store each element key and its frequency value. So each element is a key and its frequency is a value, and then we are iterating through nums and incrementing the frequency of each element using get or default to handle new elements. Default frequency is 0. And then the step 2 is min heap. We are using min heap to keep track of the top k frequent elements, and here I'm creating a min heap using a priority queue that stores arrays of element and frequency sorted by the frequency, index 1 of the array, and the comparator a comma b is like ensures the smallest frequencies at the top, and it iterates to the hash map entries, and it adds each element frequency paired to the heap as an int array, and If the heap size exceeds k, it removes the element with the smallest frequency here, right here. And this ensures the heap always contains the k most frequent elements seen so far. And then here we are extracting the k elements from the heap. We are creating the result array of size k, and we extract the elements from the heap by polling k times, taking the element index 0 of the int array and placing it in the result array, and it fills the array from the end k minus 1 to 0 to maintain a natural order. And yeah, so now I'm going to have an example walkthrough. So let's take this example. Nums is equal to 1 comma 1 comma 1 comma 2 comma 2 comma 3, and k is equal to 2. So here in the first step, we are iterating through nums, and when num is equal to 1, frequency map is one comma 1, and when num is equal to 1 again, frequency map is going to have 1 comma 2, and when num is equal to 1 again, frequency map is going to have 1 comma 3, what happened? No, the whole code went away. Yeah. So now I'm going to have an example walkthrough now. So the frequency map is going to have these values, and then we are going to take a look at the min heap processing. So here we are initializing an empty min heap, and we are processing the frequency map entries. So here first we are adding one comma 3, and heap is going to have one comma 3, and then we are adding 2 comma 2, and heap is going to have 2 comma 2, and then we're adding 3 comma 1, and heap is going to have 3 comma 1 and 1 comma 3, and 2 comma 2. So now the size is greater than k is equal to 2. So now we are removing 3 comma 1, and heap is going to have 2 comma 2 and 1 comma 3. Actually, so now we are going to extract the result. So we are polling the heap, and we get 2 comma 2. So result of 1, it's going to be 2, and so the result is going to be 1 comma 2.